Welcome back. We're going to finish up our lesson here by talking about linear programming. And please be sure to take good notes because I know this is probably brand spanking new to some of you. So you're going to really want to know what you're doing later when you have some problems to practice on. So linear programming is a method for finding a minimum or maximum value of some quantity given a set of constraints. The constraints in the linear programming situation form a system of inequalities. Basically, it's the same stuff we've been doing. And the shaded region now we're going to call the feasible region. Okay, so that feasible region is the thing that contains all the points that satisfy the constraints of the system, or in other words, it contains all the possible solutions to the system. So the quantity that you're trying to maximize or minimize is going to be modeled now with what's called an objective function. Okay, objective meaning what is our objective? Are we trying to find a maximum or are we trying to find a minimum? We're going to create a function that will help us to determine what the maximum and minimum of the system will be. And oftentimes this will be maximizing either profit or it'll be minimizing the cost. Okay, so when we can examine the feasible region for the possible solutions, the vertices or the corners of that region will help us find the max and min or values that will solve the problem, and we'll see how that works in just a second when we look at this next problem. So we have this word problem. It says you are screen printing t-shirts and sweatshirts to sell at the Polk County Blues Festival and are working with the following constraints. Now there's a whole list of information here, and I'm going to show you a way to help keep things organized because it's a lot of info and you need to have it all kind of set up so that way you can set your inequalities effectively. So the question will become, how many t-shirts and how many sweatshirts should you make to maximize your profit? How much is the maximum profit? Let X be the number of t-shirts and let Y be the number of sweatshirts. And I want to point out that for this particular problem, they've already identified X and Y for us. So we don't have to write let X be, let Y be, etc. However, if they had not done that, make sure you do that because that's always going to be your first step with these word problems. You have to identify your variables. So we're going to be using these constraints now to set up a system and then also a profit objective function. Okay, and ideally we're going to follow about 4 steps here. So step 1, and I've copied down all those constraints again. Step 1 is going to be make a table. Okay, so we're going to organize this information into a table. And as I was reading the problem, I see t-shirts, those are X's, and sweatshirts are Y's. We're going to have totals for these things. I see minutes. I know I'm going to have a number of t-shirts and sweatshirts. I know I'm also going to have a cost because I see supplies cost money. It's a true fact of business. You know, you're trying to make money, but you got to sometimes spend money first. And then, of course, we're going to have our profit, which will be our function. Okay, so let's go ahead and start filling things out. And I'm going to utilize the box again. So going down to the table. Okay, we're going to fill in the minutes first. And it says that for t-shirts, we have 10 minutes to make them. Okay, so for t-shirts, it's going to be 10 minutes per shirt or 10x. So I'm going to write in here 10x. And then for sweatshirts, I can see over here it says sweatshirts take 30 minutes to make. So I'll do 30y here because it's 30 minutes per sweatshirt, and I'm going to be adding these things to make a grand total. Now that total, it says that you have at most 20 hours to make shirts. Now it gives us this problem in hours, which is a little bit of an issue because you can't mix units. So we're going to have to calculate how many minutes are in 20 hours. Okay, so I'm looking here. These 20 hours. I want to convert that to minutes. So there are 20 hours. How many minutes are in an hour? Well, there's 60. So I'm going to take 20 times 60. And that's going to give me 1,200 minutes. Okay. So we're going to go ahead and plug in that info into our table. I'm going to move that back down there. So our total, erase that real quick. We're going to put 1,200. Okay. Now, this says we have at most 1,200 minutes. So we definitely want to keep our time under that. So we're going to say this is going to be less than or equal to 1,200. Now, going into the number of t-shirts made, that's just going to be X. Number of sweatshirts made is just going to be Y. We're going to be adding these things. And then our total then, it says you want to have at least 50 items to sell. So we're going to say these things should be 50 or more. So in other words, we want this to be more than 50. Okay, or equal to, we have to have at least 50, so ideally we'd like to have more, but we'll see what happens. And then we're going to do the cost here, so I have to scroll up a little bit. It says t-shirt supplies cost $4, so that's $4 per t-shirt, that's 4x. And then we're going to have the cost of the sweatshirts, so sweatshirts cost $20 each, so that's 20y. And that total cost, we want to spend no more than $600. So ideally, we don't want to spend too much money on this thing. So I'm going to go ahead and move my box over just a little bit and say that $600 is going to be our total, but ideally we'd like to be less than that. Okay. Now, finishing up here, we're going to talk about profit. So let's go back and look at our profit information here. Profit, it says t-shirts make a profit of $6. So it's $6 per t-shirt. So I'm going to put in 6x for the t-shirts. Plus, sweatshirts actually make a pretty hefty profit of $20. That's awesome. And then we don't actually know what this will be because ideally we're just trying to maximize the profit. So this is actually going to be an equation that is a function, and it's our objective function. We're just going to say it's going to equal P, or in other words, it'll be 6x plus 20y equals P. And I'm just going to highlight that guy too because we want to make sure that we recognize that that is going to be our profit function. And that's not actually something that we're going to be graphing on the paper. Okay, so continuing on, you can see there I have the table all filled out. And then it says set up a system and objective function and prepare to graph. So let's set up our system here. So again, using our information here, we have 10x plus 30y. That's our first one. Actually, our first one should be, let me erase this real quick. Our first one should be, of course, because we can't have negative t-shirts or negative sweatshirts, x should be greater than or equal to 0, and y should be greater than or equal to 0. Always, 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 always include that. Then we'll say 10x plus 30y. Oops, there we go. 30y is going to be less than or equal to 1,200. And of course, going down, we have x plus y. That is going to be hopefully greater than, but it could be equal to, greater than or equal to 50. And then we have 4x plus 20y. And that's our cost inequality. So we want to keep that under, keep the cost low, under 600. And then, of course, we're going to have our objective function. I'm going to stick that guy over here because this is our system over here on the left. Our profit function, we're going to say P equals 6x plus 20y. Okay, and this is what we're going to try to maximize after we graph things. Now, ideally, we are going to convert all of our inequalities into a graphable form. Okay, and again, I trust you can do that. If you feel like you cannot, make sure you try it on your own and then ask questions if you need to from your teacher. But going down, if we were to convert everything to a graphable way, this is what our system would look like. Okay, and we would graph the following on our graph. Now, this graph actually ends up being rather tall and very, very wide. So I just kind of narrowed down the main points that we actually care about, that being the region that ended up being shaded. Okay, so this area right here, this area in yellow, this is the feasible region. And you can see there it's got 4 corners or 4 vertices. We've got A, B, C, and D. Okay, and so our goal now is, in our step 3, is to graph it, which we did, and then identify the vertices. So I want to identify what we've been given here. So taking a look here, I'm going to move this down. We have point A, and it's always a good idea to label them as letters because that way you keep things organized. Point A was actually at X was 50, Y was 0. Point B was at the point 25, 25. Remember, always go right or left first, then up or down. And then we've got C, which was actually at the point 75, 15. X was 75, Y was 15. And then D was a point 120, 0. Now I know it's kind of hard to see where I'm pulling these numbers from based on the graph I've provided there, but please know that if you were to graph this yourself on a very nice wide graph, you'd be able to see these points more easily. Okay, this is all kind of shrunk down, as it were, but trust me, these are the vertices. Okay, I double checked myself. So we're going to continue on. We've got the vertices identified. Now, step 4 says, evaluate the objective function at each of the vertices to determine the max or min. So you can see there I've typed out the vertices. Okay, so I just kind of moved these down just so it was easier to work with. And what we're going to do, since each one of these contains an X and a Y, okay, we have an X in the left column for all of these. So this is X. This is Y. Okay, we're going to plug those into our objective function. This guy right here, where we had P equals 6x plus 20. Do you remember him? He was from 2 slides ago. We had him right here. Okay, right there. So we're going to plug in these X and Y values into our function, and we're going to do it for each point. And it does get a little tedious, but it's a good idea to do it anyways, because you need to identify what total profit will be given by these different X's and Y's. So the first point A would give us $300, point B $650, point C $750, and point D is $720. You're looking for the one that's the most, and it ends up being at point C. This was our answer. So you can say you can maximize the profit by selling 75 t-shirts because that was X, and 15 sweatshirts because that was Y. The maximum profit is $750.